I basically monitor ice caps in the polar regions using satellite measurements. We complement the satellite observations with data acquired in the field. Basically, we dropped several GPS stations over the glacier to monitor the speed of the glacier. So the ice sheets loses mass by two means. One is through meltwater running into the ocean. The second way glaciers ice sheets lose mass is through calving events. That is the break of huge icebergs from glaciers into the ocean. So in the case of calving events on glaciers, they're usually found on glaciers that flow very fast into the ocean. So we're trying to measure the speed of that flow. Greenland has experienced abrupt changes in the last 20 years. The whole Arctic is particularly sensitive to warming. This is pretty evident because when you have rising temperatures, you have an increase in melt, and the melt rates in Greenland has been increasing exponentially since the 90s. A lot of what we do is therefore new. We have been observing the last few years melting rates and melting events that hadn't been forecast or expected at all. And what we try is to improve our understanding of those mechanisms and how it's linked to the global climate system. The satellite era, as it's known, started in the 60s. So in terms of climate, this is not a long period of time to monitor changes. But there's been some glaciological studies before. Usually they were made by geological surveys teams trying to map the topography of the glaciers and the ice sheets and define boundaries. It started picking it up a little bit in the 70s, when research stations in Greenland start gaining importance in terms of research. It wasn't until the big melt events in the 90s and the identification of glacier speed up, in which true global concerns start rising for what was happening in the Arctic as a whole. So in a way we are in new territory, but also we are in a position in which technology allows us to monitor the changes with very high accuracy. Actually, I was in Greenland camping during those melt events, and what I can tell is that the glacier we were monitoring had record speed in its flow. We were, working on t-shirts on an environment that usually is under freezing conditions, seeing a lot of meltwater running to the oceans. There were floods in certain areas. The main base of operation for the United States Polar Services got flooded by a river that just went crazy from all the meltwater, and it just shattered any previous record. But as it is this year, there was, although the melt events weren't as intense, the temperatures continue to rise, and every year for the last 10 years has been the warmest. So although, again, in climate scales, 10 years doesn't really mark a trend, what we've been seeing is something that hasn't been seen in centuries. Well, we have to understand that the Arctic environment is not isolated from the rest of the Earth. There's two ways that are pretty obvious. One is that freshwater input from the ice sheets modify the ocean circulation, which is one of the control factors of Earth temperature and climate. Another factor is sea ice cover. So as it has been seen in the media, sea ice cover has shrank in the last 10 years, which means that the radiation coming from the sun is being absorbed by the ocean, and we still don't understand what are going to be the consequences in the long run. But what we know is that these mechanisms are having negative feedback loops. So decreasing sea ice cover means more absorption of the ocean of solar radiation, which in turn means higher temperatures and more melt of the sea ice. Well, everything. It's just so far away from everything I grew up with, and culturally, the people that live there live so differently for us. The environment is just amazing. But if I were to say one thing that really strikes me is the vastness of the ice sheets. It's the only place where I truly comprehend how big the Earth is and how small and fragile we as humans are, and being completely isolated in an ice sheet at -40 really put things in perspective. If I could pinpoint one event in my life, is that I come from an engineering background, which means that as a kid I was the stereotypical boy that just will disassemble any gadget that I could put my hands on. But also I was very into nature and the environment, and especially the weather. I couldn't understand why we could not forecast weather, why it was so difficult. So I studied engineering, and I wanted to study remote sensing, which is basically monitoring of the physical phenomena by instrumentation that is placed away from what you're studying. And I specialized specifically in weather radars, and I was working in a research group that had an atmospheric observatory in Antarctica. So for 3 years in a row I was sent to Antarctica, and although my work there was just basic hardware maintenance and a few calibration experiments, the experience itself was a life-changing event for me. I discovered the amazing environment of the polar regions, and also was awestruck by all the research done by all these people, from biologists to paleontologists to climatologists. It was just amazing, and I just knew this is where I want to stay. That's the kind of research I want to do for my life.